In this video, I'd like to talk about the math question of the day for Thursday, April 13th, 2023. And with this problem, we need to simplify this quotient, these two rational expressions. And arithmetic with rational expressions is typically something taught in Algebra 2 or maybe even in a pre-calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, our first step is to change this to a multiplication problem, since multiplication is a much simpler operation when dealing with fractions. And remember, let's say we have, as an example, 1/2 divided by 2/3. When we are dividing fractions, we keep the first one the same, we change the division to multiplication, and we flip the second fraction. And once we do this with multiplication, we just go straight across. 1 times 3 is 3, 2 times 2 is 4. So multiplication with fractions is just simpler, so changing this to multiplication makes sense. Now we can start by just rewriting this first one. We keep that one the same, so we'll write 3x squared minus 8x plus 4, all divided by 9x squared minus 4. And we change this to multiplication, and then we flip this second fraction. So now we have 9x squared minus 3x minus 2. And all of this is divided by 3x squared minus 5x minus 2. Now, these expressions are a little bit complicated. We have quadratic expressions in the numerators here and in the denominators. But we can try to factor these. And if we factor each of these expressions, we may be able to make some cancellations. And since the coefficient on at least these three quadratics is not 1, we can use factoring by grouping to factor each of these. But this quadratic here is a special case. This is a difference of two squares. Since notice, we have 3x squared minus 2 squared. And for a difference of squares, let's say in general, if we have a squared minus b squared, this can be factored into a minus b multiplied by a plus b. So this one we can factor fairly simply, at least relative to these other ones. But like I mentioned, for these other three, we will need to try factoring by grouping. And of course, there is the chance that these don't factor, since most quadratics do not factor in a simple way. However, when learning these arithmetic problems with rational expressions, the problems are generally crafted so that they are factorable. So we can at least try to factor them, since in all likelihood they probably will work. But if we were to, let's say, change any of these numbers by just a little bit, like maybe make that a 5 or this an 11, then these expressions will no longer be factorable. So just slight changes make it very difficult to factor these. So let's make a little bit of room and we can keep working. Let's start with this numerator here, this 3x squared minus 8x plus 4. And when factoring by grouping, the general idea is that we want to split this middle term into two separate terms where a and b are just the coefficients. And to figure out what those coefficients are, we will need to ask ourselves which numbers add to -8. We can do addition up top. And which numbers multiply to the product of the coefficient on x squared and the constant term. So they multiply to 12. And I should mention, for the addition part, they have to recombine to -8x. So when we look for those two numbers, a and b, that add to -8, that should make sense. Because when we split these up into two terms, or when we split -8x up into two different terms, we should be able to re-simplify back to what we start with. So this part is intuitive, but I will mention that why they need to multiply to 12, the coefficient of x squared multiplied by the constant term, that is absolutely true. They need to multiply to 12 in this case, but the intuition for that is lacking. We can certainly prove that it's true, but in my experience, I've never seen an explanation of that where I gained a lot of understanding for why this has to happen. Like I mentioned, you can prove it, and it's absolutely true, but it is lacking in intuition. So most students will just memorize that fact. But for this specific quadratic, when factoring, we're looking for two numbers that add to -8 and multiply to 12. So if you're not sure, you can start with 12 and just look at its factors. And in all likelihood, they both have to be negative here, since they have to add to a negative number, but multiply to a positive number. So in fact, they are both negative. So we can look at -1 and -12, -6 and -2, and -3 and -4 if we want, but we can actually stop since this is what we're looking for. So the two numbers, A and B, that we are seeking are -6 and -2. So we can now rewrite this as 3x squared minus 6x minus 2x plus 4. And now we use factoring by grouping. We pair the first two and the second two together and pull out the greatest common factor. So from these, we can pull out a 3x. We're left with x minus 2. And you can always check these by just redistributing to get back what you started with. And here we can pull out a -2, so that we're left with x minus 2. And one way to check that you're doing this correctly is you should end up with the same expression in both of these parentheses. And we can now factor this expression out from both of these two terms. We get x minus 2 on the outside. We're left with a 3x here and a -2 there. So all of that work, we just factored this first quadratic in this first fraction in the numerator. And of course, we know we can factor this denominator using the difference of squares method. So let's quickly do that one in orange. We're looking at 3x, and we're squaring it, and we're subtracting 2 squared. So this will factor into the first one minus the second one, ignoring the squares, and then multiplied by the first one plus the second one, ignoring the squares. And again, to check your work, you can just redistribute this to make sure you end up with what you started with. So we did the first fraction. Now we need to look at this second fraction here. We can do this one in green. Let me make just a bit more room so we can keep working on that. We have 9x squared minus 3x minus 2. We will again use this grouping method, so let's make our cross. We know the numbers have to add to -3, and they multiply to the product of the coefficient on x squared and the constant term, which is -18. Since they're multiplying to a negative number, we know that one has to be positive and one has to be negative. So let's look at the factors of -18, and they have to add to -3. So you can write out the whole list, but you'll be able to see that -6 and 3 will work since they multiply to -18 and they add to -3. But if you didn't notice that right away, just start writing out all the factor pairs of -18. You do -1 and 18, 1 and -18, 2 and -9, -2 and 9, and so on. But sometimes you'll notice it very quickly. So we have -6 and 3. So we can break this up into two terms. We have 9x squared minus 6x plus 3x minus 2. We group the first two and the second two together. We can pull out the greatest common factor, which in this case we can pull out a 3x. And from this one we're left with a 3x. Here we're left with -2. And for the second pair, all we can do is pull out a 1 so that we still have this 3x minus 2. But by pulling out 1, it just makes it clear that we do have the same expression for each of these terms, which we can now factor out. We pull out the 3x minus 2. Here we're left with a 3x. and here we're left with a 1. So now we factored this one, and lastly, we just need to factor this expression, again, using our grouping method. So let me make a little bit of room so that we can hopefully keep that on the screen. We have 3x squared minus 5x minus 2. We'll need to use our cross method again. We're looking for numbers that add up to -5 and multiply to 3 times -2, which is -6. And numbers that add to -5 and multiply to -6, since they multiply to a negative, one has to be positive and one has to be negative. And we can start by just looking at the factor pairs. We can do 1 and -6, -1 and 6, and 2 and -3, -2 and 3, but it looks like this first one will work since these will add to -5. So 1 and -6, those are the two numbers we're looking for. We can break up this middle term here into minus 6x plus 1x minus 2. And notice that we can now pair them. We can use the grouping method. From the first two, we can pull out a 3x, so that we're left with x minus 2. And from the second pair, we can't pull anything out except for 1. And we will have x minus 2 in parentheses. We can now factor x minus 2 out from each of these two terms, so that we get x minus 2 multiplied by 3x there and plus 1 there. So now we factored all of our expressions and we just need to put them together. So let's go back up. We can continue working on this. We are running out of room here, but let's do it over here. And we'll just put it together piece by piece. We did this numerator here in this first fraction, and we found that that is really just x minus 2 multiplied by 3x minus 2. That's right here. We followed this logic, and it's divided by that difference of squares, which is 3x minus 2 multiplied by 3x plus 2. And then we multiply it by this second fraction. And when we factored this numerator, this 9x squared minus 3x minus 2, that was right here, we got 3x minus 2 multiplied by 3x plus 1. So we can put that in, 3x minus 2 multiplied by 3x plus 1. And we'll divide it by this quadratic here, which we factored down below a little bit. Right here, that's x minus 2 multiplied by 3x plus 1. So x minus 2 and 3x plus 1. Let me just quickly make sure I did this top right one correctly. That was 3x minus 2 and 3x plus 1. Okay, so it looks like everything worked. We were able to factor everything and simplify. And at this point, we can make cancellations. If we have something in the top and the bottom, they will cancel out. So it looks like x minus 2 can cancel out. This 3x minus 2 will cancel in the top and bottom. And this 3x plus 1 will cancel in the top and bottom. So all of this will simplify to 3x minus 2 over 3x plus 2. So this should be our final answer. But if we want to make sure of this, let's go back to our original problem. What we can do, and this is a bit tedious, is pick some value for x. Maybe we can pick 0 or 1 or some simple integer value. Let's start with 0. And if we plug this in, we'll get some answer. And we should get the exact same answer if we plug it in over here. In fact, we can do this very quickly. If we plug in 0, we'll just get -2 over 2, which is -1. So when we plug in 0, we should get -1. But let's try that here. If we plug in 0, all these terms just go away. So we get 4 over -1, or -4, which simplifies to -1. We're dividing that by -2 over -2, which is 1. And -1 divided by 1 is -1, which, as you saw here, was the exact same thing we got with our simplified expression. And you can try other numbers if you want, just to feel more confident, but this is a simple, though sometimes tedious, way to check that your original expression and your simplified expression are equivalent to each other and produce the same outputs when you choose some input.